welcome all. We will start our today's Ferro Talk show number 17. Guest speaker today, Dr. Subhash Patankar. Today's topic is the strengthening with Ferrocement. On this, he has done a lot of research and also some case studies he is going to present today. To briefly introduce Dr. Patankar sir, he is a professor at College of Engineering, SRES College of Engineering, Kopargaon in Ahmednagar district in Maharashtra. Uh, he has worked for 1 year on site in a private associate, but later on joined these academics. He has achieved so many awards at national level, which was for Flyash contest. So he has also worked with Flyash, and he has also got the Best Innovative Teacher Award by Pune University in 2019. Also got the Outstanding Achievement Award by Institution of Engineers in 2017. Many such awards he has already bagged, and now this today's novel concept of strengthening of core structures with the ferrocement, he has come up with his presentation. So let us hear his presentation first, and then we will have interaction with all the participants. So I request Dr. Patankar to start his presentation.
Strengthening of existing RCC structure by using the ferrocement technique. As we know that concrete is strong in compression but weak in tension, and therefore steel reinforcement is embedded in concrete on tension side. But this combination cannot convert the concrete into an elastic material. Now, how to effectively utilize the concrete? Number one, by pre-stressing. This is the one of the technique which can convert the concrete into elastic material. Second, by introducing the fiber in concrete. And the third, which is very, we can say that the very good from the we can say that the structural strengthening point of view, that is the ferrocement technology. This is the unique technology which convert the concrete into elastic material, which enhance the tensile strength of this composite. And that's why today we have discussed about the how to strengthening using the ferrocement technique. Most of the structure which were constructed after the 1980s, like bridges, building, water tank, etc., deteriorate in the form of steel corrosion, concrete cracking and spalling. Nowadays, large number of existing structure need major repairs just after the 10 to 15 years. This is the today's scenario. Many structures fail or deteriorate before completion of its intended lifespan. It might be due to poor quality of material use, improper mix design, attack by environmental agencies, use of slender column, less reinforcement provided, improper curing, lack of supervision and poor workmanship, speed of the construction, and less depth or thickness provided in the flexural member. These are the few reasons that I have pointed out. Now, one more reason is there related with the durability, that is the corrosion, internal damage caused by the corrosive action of external chloride on reinforcing steel. That is also one of the major reasons. And we know that due to the corrosion, what happens? The reinforcement expand. The diameter of the reinforcement increases 6 to 8 times its original volume, and that's why it develops the tension to the crack, tension to the concrete. And we know that concrete is weak in tension, and that's why the section or structure is deteriorated. The assessment, design, and implementation of the durable repair to an existing structure are more complex as compared to new construction. Repair material and the old existing material will act as a composite but difficult to properly bonded. The concrete repair expert must diagnose the root causes of failure of structure and present condition to establish the repairing strategy. Now, why we go for the repairing or strengthening? The different structures were designed and constructed on the basis of strength, safety, serviceability, and durability as economically as possible. Due to the high load demand, existing structure may require strengthening to fulfill the present requirement. Nowadays, repairing and rehabilitation of existing structure is become a major part of construction activities. Most of the rehabilitation work consists of repairing old deteriorated structures by new material or by jacketing. Now, various methods generally which is used or popular in the strengthening. The structural upgradation of concrete structure can be achieved using by any one of the different methods, either by reducing the span by providing the additional supports, pressure grouting with high bonding material like epoxy, fiber wrapping, jacketing, external or internal post-tensioning system, section enlargement, or a combination of these techniques. And apart from this, ferrocement is also the best technique. Now, these are the few photographs showing the techniques used in the strengthening of the column. Now, the structural concrete strengthening, first is the bonded steel elements, which was developed in 1960 in Switzerland and Germany. Steel elements are glued to the concrete surface by a two-component epoxy adhesive. To improve the shear and the flexural capacity of the structure, the steel used and the steel plates. Steel sections are like steel plate, channel, angle section, or we can say that the built-up member. In addition to the epoxy adhesive, mechanical anchorage are also used to shear the external loads. Second method, which is more popular in India, that is the jacketing. It is mostly used for strengthening of column and beam. The main purpose of jacketing is to increase the seismic capacity of the moment resisting frame structure, to increase the flexural strength of column by longitudinal fiber reinforcement provided, to increase the concrete confinement and shear strength by transverse reinforcement. And generally, we have preferred the circular cross section of the column. Now, this is the types of the jackets: reinforced concrete jackets, second steel jackets, third one is the fiber wrapping. We use the different polymer sheets. Similarly, external post tensioning in India, actually it is not much popular, but out of India it is more popular. It has been used to increase the flexural and shear capacity of the reinforced and prestressed concrete members since 1950. The external force are applied to the structural members using post-tension cable to resist the additional loads. That means we can resist the deflection, and due to the prestressing, definitely post-tensioning, we can increase the capacity of the beam. One more popular system, that is the section enlargement, either by removing the cover, and then we have after grouting, or we can say that after anchoring the proper reinforcement and the stirrups, we have increased the section. This is also one of the methods. थोड़ा fast घेतो. Case study on the ferrocement jacketing. The main objective of present study is to strengthening the existing RCC structural element by using ferrocement technique after checking the strength of the beam column by NDT, non-destructive testing, Rebound Hammer ultrasonic concrete tester, and we can say that the destructive and partly destructive and partly non-destructive, that is the core test, concrete core test. And after strengthening the existing RCC element by using the ferrocement technique, the improvement in strength can be checked by again NDT test. For for strengthening of existing RC structure, we have selected G+2 frame structure of Sri Ganesh Junior College, Korare, which was constructed in 1916. And after 3 years of construction, NDT was carried out due to excessive vibration and cracking observed in RCC slab beam. Observe that the strength of column and beam and also slab were less than 15 MPa, but these elements were designed for 25 grades. Due to its poor strength, slab are vibrated during walking, while some vertical cracks were also observed in the beams. So after NDT by Rebound Hammer Test measurement, management has decided to strengthening the RCC element under the guidance of Dr. B.N. Divekar sir, Chairman, Ferrocement Society, Engineer P.P. Lele sir, Engineer B.P. Divekar sir, and the members of the, these are the members of the Ferrocement Society of the India. This is the building which we have strengthening using the ferrocement techniques. Sequence of
this building. All the beams have been strengthened, or only one?
Not. We have strengthening the some beams which is having the strength less than 20 MPa.
How many beams you have treated?
Around 25.
25. Oh, it's a big number. Okay,
Yeah.
good.
Yeah.
And only beams or even columns, slabs?
Columns and slabs are also.
Column is also there. Slab is,
Okay.
yeah. Slab is also there. Column is there, also there, and beam is also there, and even staircase also strengthening.
Okay.
Because there is a problem of the not only the strength but the supervision. Lack of supervision is also not actually supervision. There is a problem with the supervision also.
Okay.
Whatever the grade they have mentioned M25, it is not M25 because they have used the crushed sand and the and actually it is not crushed. VSI make it is not VSI. It is the dust taken from the we can say that the stone quarries, and that is the major problem. So these are the sequence of strengthening work: NDT of column, beam, and slab, mixed design of mortar, collection of material, preparation of the surface, then wrapping of the steel framework, welded mesh, and then chicken mesh, and application of mortar. Then after that, curing, then NDT testing of RCC element after the ferrocement applications. Now this is the Rebound hammer use. That is the prosaic make. The costing is around 2.64 lakh. So this is the NDT result of the concrete core test taken on the floor slab. Here it is observed that rebound hammer, ultrasonic concrete tester, and the core test. We have taken the core. The diameter of the core is 70 mm diameter and the length is 140 mm. And here also we have really surprised. The depth of the slab is 160 mm. But we have taken the core, total core, the thickness of the slab is 140. At some places it is 130 or 135 also. That means there is it is not properly, centering is not proper. So this is the rebound hammer test, span 1, 2, 3, 4 and 5 in the building. Average compressive strength is 13 using the rebound hammer, 13, 12.5, 15 average. 13.50, 14.25 and 14. This is the compressive strength of the slab. And for every span, we have select the around 30 to 35 points where the there is no steel reinforcement across the rebound. Then ultrasonic concrete velocity we have find out. Here it is observed that the velocity, because the concrete is undulated, it is not, the surface is not smooth, and that's why the velocity is also less. It is 2.225 or 1 point something like that. That means the compressive strength using the ultrasonic we get less than 10 Newton per mm square. And third, we have going for the core test. We have select the core of the slab at different places. And here it is observed that the mass density of this core is not even 22. That means the mass density of the mortar. This is the concrete, but the mass density of the concrete is less. That means that it is porous. And that's why the compressive strength of the core, it is 8.36, 8.87, and 10.11 and 9.86, which is very, we can say that the it is less than 50%, because the grade of the concrete is M25. And here it is observed that the after testing the core, the compressive strength is just 10 MPa or less than that. These are the NDT results for the column. Column number is also mentioned as per the plan: C8, C7, C8, 17, 18, 19, like that, up to 35. And this is regarding the ground floor. This is a second floor, first floor, like that. We have taken the only random column, not all the columns. And here it is observed that the using the rebound hammer, the compressive strength is 17.50, and that means the highest, and lower is 10.50, like that, 10.15, then 10. That means the lowest is 10 and highest is 17.50 for all these columns. And here also the mass density is also again less. Generally, in case of concrete, we have generally assumed the compressive mass density is around 2400. Here is observed that 21, 22, like that. That means again the concrete is not properly compacted. That is also, that may be affect the compressive strength. And this is the core test. And here also core testing, the compressive strength of the column again 14.05, 12.36, 10.03, like that. Okay, again, which is and the grade of this concrete is M25, and the compressive strength is less than 17. This is the situation before strengthening. Now this is the NDT results of the beam. See here, the number is also mentioned, that is the B63. The size of the beam is also mentioned, and span is 10 meter. The average compressive strength, we have select the compressive strength using the rebound hammer, and not only for one place, we have taken the around 30 to 35 points, and after that the compressive strength is 19.50, like that, 17.50, 15 Newton per mm square, and the grade of the concrete is M25, and mass density is again 23, highest is 23.27, and lowest is 21.59. That means again the concrete is not properly compacted. And using the core test, the compressive strength is 17.63, 15.89, like that, and highest is 18.032. Now this is the situation. Now the consultant of this building, who has designed this building and suggested the grade and everything, supervision, he suggests this type of strengthening. The strengthening scheme 1 for the beam. Here it is observed that they have used the ISMC, that means the channel section at the top and at the bottom, like that, and then it will be connected with the plates.
This is for columns, no? Or beams.
Yeah. This is for the column. This is for the column. Similarly, for the beam also we have used the angle section. I can show that also.
Okay, so this is C section for column.
This is the scheme number 1. That means, actually he was suggested, this is the scheme number 1. That means two channel will be used face to face. This is the second scheme, again for the column. This is the RCC column, and then these are the plates. Angle section is provided, ISA 75 by 75, 6 mm thickness, and then these two angles are connected with the batten plates. The thickness of the plate is also 6 mm. This is the second scheme. And for the beam is suggested like this. That means the angle section is provided at the junction of the slab and the beam, and these are the two angles. That means the one angle is at this corner and another angle is at the angle, and these two will be connected with the plates. That is two 10 mm thick fastening is also done. These are the fastener at particular space, and the distance between each plate is 300 mm. This is for the beam.
That plate is what is the width of that plate? It is not continuous.
Width of that, actually width is sir, it is already given. 10 mm thickness is given. Sorry, not 10 mm.
8 mm.
It is 75 by 25. 75, and throughout the depth, this total depth, okay. And this will be connected with the help of fastener.
Okay.
Thickness is 6 mm. Now this is the strengthening scheme for the beam. These are the plates, and these are the fasteners. Okay. And this distance is 300 mm. And angles are provided at the bottom. I can show also this figure. One beam and one column is already done before strengthening by using the ferrocement techniques. And for the ferrocement, we have designed the mortar in our laboratory with the help of Lele sir. We have used the ultratech cement 53 grade, compressive strength at 3 days is 28.33 and at 7 days is 39.11. Fine aggregate crushed sand, we have used same crushed sand but with the quality. Fineness modulus is 3.05, conforming to grading zone 1 as per IS 383 1970, and the plasticizer used super plasticizer Sika 3532 for the mortar. This is the selection of the final mortar mix. Here we have considered water to binder ratio or water to cement ratio is 0.30. Cement, sorry. This is the super plasticizer 0.01%, and we are getting the slump of 35 mm, and the compressive strength at 28 days is 38 MPa. This is the after making the mortar of this proportion we get, that means the 1:3 is the proportion. Water to cement ratio is 0.30 with the super plasterizer is 0.01%. And the compressive strength after 28 days is 38. As usual, in ferrocement, we have used the vertical bars, then square mesh, and then chicken mesh. No issue for that. Then after, this is the NDT of existing column using the rebound hammer. I have shown the comparison. C96 ground level, the average rebound number is 38.2, the standard deviation is 6.3, and the average compressive strength is 15. Actually, we have designed for the M25, and these are the results: 15, 12, and 14. This is at the ground level. Then NDT of the existing column after strengthening by ferrocement technique.
Dr. Patankar sir, just one small
Highest.
You have shown those angles or C sections. So which one you have used for strengthening for beams and columns?
Steel section, na?
About steel section, you have said the consultant has proposed two options. One with angles, corner angles, and one with C section.
Actually, we have used the not C section, channel section, angle section we have used.
Okay.
But this, sir, actually this was done before contact the management to us.
Okay.
This is already done before contacting us.
So you have just tested it. The construction was done by. Okay. And how that? After that, the fixing these angles and those plates with ankles. Then how that ferrocement is applied? Is it over that?
No, sir. They have done only for the one beam and the two columns. This is done only for the two column and one beam.
Okay.
Till they are not satisfied, management is not satisfied. But after that, he contacted to me.
Okay.
And that's why then I have contact to the Dr. Divekar sir and PP Lele sir, and he visited, and then we have finalized the ferrocement technique.
So what is the final section adopted? That is what I wanted to know. You are not sure.
I can show
of that.
I can show, sir. You can show. Yes. Because I can show, sir.
Okay. Please.
2 minutes, sir. I can show.
Okay.
So this is the average compressive strength. This is the detail. That means the rebound number 0.9 for the column number 96 ground level. Average compressive strength is 32, and strength before strengthening. Here it is. These are the strength after strengthening. That means after using the ferrocement technique, 32 MPa we have achieved the 32 MPa using the ferrocement technique. And here this is the strength before strengthening. It is 15.50. That means around we can say that the 106.45% enhance the strength. Second, this is the second column, C 166. Average bond number is 47.8. Standard deviation is 3.7. Average compressive strength is 30.50. And before strengthening, the compressive strength using rebound hammer is 12. Only 12. That means it is increased by 154.16%. Similarly, for the column C143, rebound number 49.1, standard deviation is 4.1, average compressive strength 31.50, and the compressive strength before strengthening is 14. Here it is observed that the improvement in the strength is 125%. So regarding similar to the column 33, ground floor 39, 41, beam number 63, and beam number 60, first floor, and this is for the ground floor. These are the rebound number, standard deviation, and this is the compressive strength achieved after ferrocement jacketing. Here this is the compressive strength before jacketing. That means the old column and the beam. Here it is observed that 15 converted into 32. That means 133% in enhancement. 12.50 is converted into 30.50. 11.50 is converted into 31.50. Like that.
Okay.
So I can show the figure.
So this is by ferrocement jacketing. No. No steel plates or the angles used here.
No, nothing.
Okay.
No, nothing, sir.
That's good.
These are the slab. Sorry, this is related with the column. This is related with the staircase. This is related with the column, strengthening of the column. Before application of the mortar, this is the after application of the mortar. This is the total column. Of course, the size of the column is increases after the ferrocement jacketing, but it is by just by 100 mm. This is the strengthening of staircase using the
100 mm on each side.
No, total 100 mm maximum.
Total 100 mm. That means
Yeah,
with plaster, sir.
Yeah.
This is the strengthening of the staircase using the ferrocement technique. Okay. Now this is the conclusion. Strengthening of the RCC column and beam can be significantly improved by using definitely ferrocement jacketing. After ferrocement jacketing, strength of the structural concrete is 1.5 to 2 times improved than the old structural concrete. Ferrocement jacketing gives better bond between the old and the new matrix due to evenly spaced chicken mesh wrap over old structural concrete and also insert with the rebarring. Excessive vibration developed in the floor cease due to the increasing size of the structural element and improvement in the bond strength. Ferrocement technique is more suitable and economical than other strengthening techniques. Structural consultant suggested the use of the steel plate for strengthening of beam of span 12 meter. The total cost of the strengthening using this technique, sir, आप देख सकते हैं, you can check. They have done the only one column and one beam. The cost of the total strengthening using the steel angles and the plates after fastening, the total cost is 8,200 including the labor cost. The depth of the beam is around 1.2 meter.
Okay.
And
this is for
this is old one.
Okay.
This is for the beam, sir.
One beam.
Yeah, one beam, only one
Okay.
beam. And while by using ferrocement technique, we have done same beam, not same beam, at second floor beam and the first floor beam, 12 meter. By using the ferrocement technique, its cost is only 17,000.
Okay.
See the 82,000 and 17,000, but there is no bonding. We have just fastening the steel plates and all these things, but even though the vibration is not ceased, but using this ferrocement technique, we have seized the vibration. We have also measured the vibration after placing the load using the sandbags.
Okay.
See the which is almost 30% of the cost of the steel plate.
So 70%.
Using ferrocement, yeah, 17,000, and using the steel plate angle and the steel plates, it is 82,000. So ferrocement technique is very much cost effective and strongly bonded with the old concrete. First of all, I can show some figures. Actually, what happens, sir? Due to my laptop is not working, so some photographs is not possible to show you. But definitely, I can share these photographs to our ferrocement WhatsApp group.
Okay.
Now, along with me, Lele sir, Dr. Devekar sir, and the Pushpamitra Devekar sir, these are the students who give some support for the testing and all this work.
From your college.
These are the these are some references, and these are some photographs showing some work. This is the one column done by the consultant. These are the angles, 4 angles, and these 4 angles are connected by the plates. That is the battening system.
Right. But this was only for 2 columns. No, you have not used this section.
They have only used 2 columns because the costing is very high. And this is the beam, sir.
Right.
This is the vertical portion. Yeah. Top column is there. Bottom column is top is angle is there, and this is also angle. These 2 angles are connected with the batten plates. Vertical, we can say that the stiffness.
So this was the method suggested by consultant, not
Consultant.
You have not used this section, no?
No, no,
So
no.
what is your
Actually,
show it? How your ferrocement jacketing is done without these steel supports?
just a minute, sir.
Do you have any
Yeah.
cross section of photograph?
Sir, we have done this. We have done this. Not this, these are the different types of the jacketing. That means the RCC jacketing. This is the RCC jacketing. This is the steel jacketing, and this is the, we can say that, the fiber wrapping. We use the carbon fibers or different polymers, and this is our work. That means we have done this vertical bars. That means the frame using the vertical rods and horizontal one, and then it will be wrapped with the square mesh and then chicken mesh, and then it will be covered with the plaster, or we can say that the mortar, rich mortar.
Okay. So how much?
But definitely I can share, sir, different some more photographs at present, due to my laptop is not working.
Share your photos, but just can you explain what is the cross section of that ferrocement material you are used? The thickness, the steel reinforcement provided, how it was designed.
Sir,
On these technical aspects, just elaborate a little. Everybody will be curious to know that.
Sir,
sir,
Yes,
sir,
yeah, yeah.
Lalit, you can explain about the
Nilesh sir,
yes, sir.
Nilesh sir,
Yeah.
can you share? Yeah.
I'd like to explain.
Yeah.
For the columns, what we did, actually, we have to wrap the column with the ferrocement. And
Okay.
we have to ensure that it is properly bonded with the RCC column. So we drilled a hole and make some insertions with the rebarring steel bars in the old column, and that was joined to the stirrups wound around the column. So
that deburring was done by breaking the column.
not breaking, drilling the holes in the column. That rebarring is essential because we have to tie that ferrocement with the column.
Okay.
It has to be bonded with each other. That is the reason. And for every stirrup, we did at least 4 such insertions.
I see. Oh, it's a
Yeah.
for
Yes,
every stirrup.
Because our column section was quite big. It was 2 feet by 9 inches, 24 inches by 9 inches. Most of the columns were of that size. So in 2 feet, at every 1 feet, there was one rebarring was done. So that way, all the stirrups are tied to the column, and then that vertical, you can see in the photograph, the vertical bars were also there. And over that, we tied that chicken mesh.
Okay.
Two
Inside,
layers of chicken mesh and one layer of
chicken mesh,
chicken mesh was half inch chicken mesh.
but no, not inside, only for outer side.
Yeah, only for outer, because inside the concrete is there.
Right.
So 3 layers were applied from outside,
Okay.
and 1 layer of weld mesh was also there. And before mortaring, we use bonding agent from phosphor. We applied bonding agent, and then mortar was applied. So we ensured that steel, not only steel, but mortar and old concrete should bond to each other. That we ensured.
So how that coat was applied by
Was applied, and then mortar was pressed.
but how that coat is applied once the reinforcement
By brush, through that chicken mesh, that we can apply because it is liquid.
Manually.
by spraying, just like paint.
No, not by spraying, manually with by brush.
Acha, so before laying the chicken mesh.
And before mortaring.
Using the towels.
Now once that welded mesh and chicken meshes are in place, how can you apply the coat on the old concrete surface?
It is liquid. It can pass easily through that meshes.
So by manually
You
by
have to ensure that surface is wet while applying your mortar.
okay.
Wet with that bonding agent. That we
Actually,
ensure.
it is mortar, sir. Mortar is there, no?
Mortar
It is not
there.
concrete.
Then we
It is
apply-
mortar, no, sir.
And the thickness of this ferrocement component, how you have designed that? How you ensure
Actually,
the increase in strength?
8 mm, 2 layers of 8 mm, it becomes 16 mm, and over that weld mesh and everything, and that you can cannot exactly tie that your stirrup around the column. There is some gap that is bound to be there. You cannot tie because these stirrups are welded. So we made the C, and then by overlapping they were tied.
Hmm.
And to make that column in plumb, originally it was not in plumb. We had to apply some extra mortar because we had to make it in plumb.
Okay.
That plumb problem was also there to some extent, maybe 15 and 20 mm like that.
Okay.
So automatically the total thickness increases.
So,
That
what is the final thickness then after
final thickness was measured. It was 40 mm roughly
40 on either side?
on either side. And
Okay.
after that, finishing was essential because it is a delicate building. Students are already there, so it was again plastered and finished with their requirement as per their requirement.
Okay. So now this my specific question is how you design this 40 thickness of this ferrocement jacketing so that you can get this much improvement in the compressive strength or whatever you want to achieve.
That is normal because normally about 40 thickness is in any way you go, we get 25 to 35 or 40 thickness of ferrocement because the thickness of bars plus cover and plus mortar and meshes, it goes to 35 32 or 40 like that.
So this is the regular nominal reinforcement you have provided,
Normal. This is normal.
right?
This is normal.
Okay.
And you can see that total strength required was we have to increase by some 10 or 15 Newton per square mm.
Okay.
And this section will give that much strength.
Hmm.
That was ensured. That how much this thickness of ferrocement will give that much strength. Due to steel reinforcement, bars and meshes and mortar. That's we get that much strength. So that was ensured that how much thickness total increase in the section that will give that much strength.
Okay, but how you ensured then that that much strength has been achieved?
That he has tested in the lab section that samples were tested in the lab as well as finished was he has carried the NDT of the section.
Sir, actually, we have cast the cylinder.
No, that is for mortar only.
Am I audible?
That is
Am I
only
audible?
for testing. I am talking about
column
the
testing.
jacketing you have done, how it was tested that this much strength has been achieved. That means it has double the strength. Because you are measuring the compressive strength of the column, entire column, including the older one,
Yeah.
right?
Sir, actually, we have done the non-destructive testing, rebound hammer.
The rebound hammer will give the only outer surface strength of that ferrocement jacketing.
Sir, old concrete, we cannot improve the strength of the old concrete, but if we have wrapped the, we have done the jacketing, what happened, whatever the new concrete, or we can say that the mortar is there, it will, if the strength is enhanced, and second, we have after anchoring all bars, definitely it gives the pre-stressing, that means tighten this mesh. And because of this, we have, we can say that we have enhanced the compressive strength of concrete, column.
No, but okay, just for it may improve or may enhance the strength, but technically, even while designing, can you ensure that the old concrete strength was say 10 MPa and after jacketing it increased to 30? You are shown in the tabular form. But how you ensure that the combined effect has been increased?
Sir,
Because
there are
you will give only testing of the ferrocement jacket. That may be even up to 50 MPa. But the combined effect of old structure plus jacketing, so that strength you cannot measure just by NDT after the completion.
Sir, there are two
It is
things.
true, sir.
Section is increased. So additional section will give some strength plus hoof strength of ferrocement. It comes into action because ferrocement has got tensile strength, and when column is loaded, that ferrocement will have some hoof stresses, and that will increase that will resist the compressive forces coming on the column.
That's true, but this is all theory. What I am trying to get it, these having
Practically, if you want to exactly
that
check
way,
the strength
Sir,
of column, you have to erect one similar column, load it before ferrocement jacketing, then load it after ferrocement jacketing. That way, you can ensure test that column in the lab or
this is
in
like
the
a prototype testing.
prototype. That is the only way, I think.
But have you done it or not?
No,
yeah.
that's a
Sir,
practical very.
sir, it is true. Yes, hello.
Yes, please.
Hello.
I am
We
listening.
have cast the we have cast the different types of the beam and the column having the lower strength. We have done the two experiment. One is having concrete having the lower strength. Then we have test the concrete cube and then prepare the cylinder, not the rectangular section. Definitely we have go for the cylinder. Then after casting the poor quality concrete, and then it will be wrapped with the ferrocement technique, and then it will be tested.
So have you done it?
Sir, yeah, we have done it.
So what is the
Second thing, for the beam also, we have failed the beam up to we have applied up to 60% strength. That means, for example, if the load carrying capacity of the beam is say 20 kilonewton, we have applied only 20 multiplied by 60, that is 120 kilonewton. 12 kilonewton, like that. And then after that, we have wrapped the this beam, failure beam, by using the ferrocement technique, and then it will be tested.
testing by?
Yeah, but definitely these photographs is not with me, and that's why I am not in a position to show all these things. But we have done all these things.
No, but whatever you are telling,
And one more thing is there, sir. One more thing is there. When after jacketing, this ferrocement jacketing, the vibration of the slab is reduced.
and that's
Before,
true. You
yeah.
what you are. I am
Before
just trying
jacketing,
to.
the vibration I have observed around 35 to 50 mm. That means when someone sitting in the on the chair, but someone walk through this floor, anyone realize someone is coming. Such vibration is done, and
Yeah, I got it.
after jacketing we get below 1 mm. See, 50 mm, 35 mm, and 1 mm. This is the we can see that this is the indirect check.
Okay.
And also we tested that with the load test. We put the
Yeah.
What test of
Sandbags.
what
We have played the sandbags.
sandbags on slab,
Yeah.
and you measure the deflection or which strength?
Yeah, deflection.
Okay. I think let us go to Divekar sir to get us satisfied. Sir, I have a specific question, another query. Maybe I am wrong, I don't know. Whatever we have seen through his presentation, that it's a kind of jacketing done to the old beam or old column. So my specific question is, while planning and designing the retrofitting work, the strengthening of that old component, for design considerations, can we specifically design the thickness of it or the reinforcement required? And with that design, we can be ensured that this much strength increase will be there after this kind of jacketing is done. Because the way or the kind of NDT they have done after that, I think it may mislead the results, because that testing is not for the total combined effect of that column or the beam, including the whole structure. It may give results only for the outer ferrocement jacket, which is certainly stronger than the old component. So, how to ensure that increase in the strengths after jacketing while designing?
Is confined by a member which is very strong in tension. Previously, their consultant had suggested a steel plate encasement,
Right.
or many other people suggest by wrapping fibers, carbon fibers and not. The idea is to confine the concrete in a member which is having higher tensile strength. But in all those cases, in steel plates which are used, or say the fibers which are wrapped around the concrete member. They have no bond with the original uh, construction, and they don't contribute to the strength also later. Fiber won't take any compression strength, or the steel plate which is used for wrapping is also not taking any compression strength. Now, if there are a number of experiments, this is about the difference between the two systems that we are using. We are using ferrocement and how it advantages, I'll tell you later. Now, there are a number of experiments conducted on confinement of concrete. As you know, in soil mechanics, we have got the triaxial strengthening of strength is found out for the soil. Triaxial test is done. On the same lines, for concrete also, triaxial strength tests are made. That means lateral confining pressure, how much it is, and how much is the increase in that core concrete, strength of the core concrete, that is what is collaborated, and there are a number of results available. There are a number of tests conducted for how much is the confinement required. There are equations uh, given by Naman, not Naman, there is some other, I forgot his name, but there are equations also giving how much is the increase in confined strength of concrete by using the tensile strength of the material surrounding. Now, in the case of ferrocement, with the system they have used, 8 mm bars at such a distance, and weld mesh one layer and three layers of chicken mesh and cement mortar of rich cement mortar, well, actually we can calculate how much is the tensile strength of that. It is already proved in many cases for a certain mix. For example, say for one weld mesh and three chicken mesh layers and 8 mm bar, 200 center to center. For that, the thickness goes up to maybe 25 to 30 mm. The total thickness is for the bar thickness plus the weld mesh thickness plus the gauges plus the cement mortar with cover on two sides. So it comes to about 25 to 30 mm. So for that thickness, how much is the increase in bond area that can be correlated with the tensile strength and compression strength of ferrocement? There are
Ah,
equations for it. We have derived it, and in that book there are equations. Now, instead of that, if you use only two weld mesh layers or only say six chicken mesh layers, how much is the increase in tensile strength and compression strength that can be equated and found out? And they are related with the specific surface. How much is the bounded area? So that is how we can ascertain that for a particular mix, for a particular combination of meshes, we have got a particular tensile strength and compression strength of the encasement ferrocement that we are doing with. Now in this case, they have used about 25 to 30 mm thickness for encasement, including plastering. Later on, the thickness increases. Now, as about that bonding chemical, as you asked, it is in liquid form. It is not in
of
form of mortar or any solid form. It can be applied with brushes, and that bond between the old structure and the new mortaring that we are making, that is what is used. That is what is used for that. That bonding chemical used. So it was applied here. Other thing is with ferrocement, we have whatever encasement we have done. It was strongly bonded with the original structure. There was no gap left. We had taken holes in it, and it was as good as it was when as a one integral structure.
right.
That ferrocement has not only acted individually, but it has become an integral part of the old structure because it was strongly bonded. So ferrocement lining and the old concrete, they are working together now. That is why you are seeing the results in the NDT test that the increase is about 2.5 times or 1.6 times, whatever he has got. So those results are due to the integral nature of that particular member that is formed. Originally, say, whatever was the size of the 600, 300 column, that is now increased. Definitely, due to increase in area, the bearing capacity of the column has increased. On the contrary, when we use ferrocement lining, say it is about say 30 mm thick,
Hmm.
it is a box type lining that we are giving.
Right.
Take an example. We take 900 by 600 mm column, original column, and that is encased with say about 25 mm uh, uh, ferrocement lining. So that outer box of ferrocement of 25 mm thick, that is also contributing, but of its own, it can take higher loads also, because that becomes a perimeter. If you take 600 plus 60 centimeter, 90 centimeter plus, that means 300 centimeters will be the perimeter, and the
Right.
thickness of that encasement, or say that walling that we are putting, is 25. That means we have got an additional area of that perimeter into the thickness of mortar,
Mm.
thickness of ferrocement, to take the additional compressive load.
Right.
And in our case, our ferrocement is using very rich cement mortars, and the compression strengths are also very higher. Even if you assume that it is 30 MPa, 30 MPa permissible compressive strength for that is 100 kilograms per square centimeter. So that 100 kilograms per square centimeter into this perimeter, area of the perimeter of the ferrocement itself will be taking much more load than the concrete column itself. Now
Right.
it is becoming integral part of the old column, so it is going to take much more load.
Yes. Yes.
All these things are considered while designing this.
Uh-huh. Well, sir, I have asked, I can say that if our hand is fractured, and after that we have wrapped the plaster. The ferrocement is just like a plaster.
Yeah. We got.
And yeah,
Yeah.
and no such method is available in existing method is available to check the actual strength after wrapping or strengthening or using jacketing or RCC jacketing. No such methods are available, but on the basis of our experience, on the basis of, we can say that the vibration before ferrocement jacketing and after ferrocement jacketing, we can say that we can improve the strength of that existing structure.
Yes. Yes.
Thank you,
Thank
sir.
you very much. Director sir, I will come back
Thank
to
you.
you again. Now, after your explanation, what I gathered is, while designing this strengthening part of the jacketing by ferrocement to the old structure, the basically three principles are adopted which give the assured and enhanced strength to the old structure. The first one you said is because of the confinement of the old section, so that it increases after that confinement, it can take the more compressive load or the flexible load, as the case may be. The second principle, what you told, is increasing the bonding, and third one is the perfect bonding between the ferrocement jacket and the old structure, right? So due to these three principles, we get the enhanced strengths, and that is the basic of the design principle. So again, I have a little doubt about the testing method. About NDT, what they have explained, NDT is not the perfect test for the composite effect of the old and new structure. Because what I see is, if you do some hammer test from outside to the newly jacketed column, it will give strength of the outer cover of the ferrocement itself. The combined effect may be in average lesser than the ferrocement, but may be increased by the with some percentage of the old structure. It may be in between. So to ascertain the exact increase in the strength, I think there need to be some other kind of tests, maybe a prototype loading, what Lele sir was suggesting, for flexural or even concreting strengths. So this way, I think we should improve our methods of testing for these retrofitted structures. Of course, these are my views. Uh, you can further elaborate if you.
In this case, laboratory testing is not possible. We will have to do prototype testing only.
Yeah, perfect.
For the existing column, we have encased it. We will have to apply load on that existing column and test it.
Okay.
Secondly, in the case of confinement, I can suggest, I can tell you how it acts. Now, when we having a cylinder, say, when we test a cylinder in compression, it starts taking load and bulges out on side. It fails after bulging. At
Right.
the center portion, the bulging will be occurring, and then due to that, the concrete will slowly fall out, and due to that, the failure occurs. Now, that bulging is confined by the tensile wrapping that we provide. That means we don't allow the concrete to come out, to bulge out, and we are confining it indirectly, and that is why its strength is increasing.
Who
That is the
place? You take
reason,
who place?
physically, how can we interpret it like this?
Right.
That bulging is avoided or prevented, and due to that, that can be done by any means,
Right.
any high tensile strength, and that is why the tensile strength member is required. You
Correct.
cannot do confinement by any other member. We want to have it, we want to have it, press it. We
Hmm.
want to have that concrete confined, that will have to be confined, that means that will be pressed in between.
Right.
And due to that, it is essential to have a tensile member, and Ferrocement is providing that.
Yes, sir. Perfectly right, sir. Thank you very much. Uh, uh, shall we go to Mohammad Sadiq ji? How did you find this new retrofitting method of old structure?
Okay, thank you very much. Actually, so far, I think I have visited this project, so I have special interest to discuss these problems. And in Bangladesh also, actually, we follow the technique of jacketing for retrofitting. And we follow two method. One is concrete jacketing, another one is ferrocement jacketing. So usually we go for concrete jacketing when the concrete strength is very low, and we just make a jacket around the column, and in the design we don't consider the capacity of old concrete, old column. So we consider total load will be carried by the new jacket. So this is very easy design. But for jacket, for ferrocement, or you see carbon fiber yeah, design. So it's actually we have no design actually philosophy, because as Debakar sir says that if we can confine the concrete, then the compressive strength will increase. But how much for how much increasing how much load capacity, how much thickness, and how much layer of chicken mesh, and how much amount of steel we have to use. Actually, I don't know the exact design for this jacketing technique. So whether it's 20 millimeter is okay, or 30 millimeter, or 40 millimeter. So in that case, actually, we have to be in the safe side, and we go for some sort of over design.
Yes.
So yeah, so, and I do agree with you. Actually, that was my question also,
Hmm.
as you said.
Hmm.
Actually, it's impossible to assess, to evaluate the strength or capacity after the confinement, after jacketing,
Right.
because it's not a homogeneous member, it's heterogeneous. So the rebound test, actually, I believe we will not get the rebound exact rebound test representing whole the member. So I rather, I don't know if I am not wrong. Our presenter is a fantastic job, but we should not compare the rebound strength before this, after this, because it may be some misleading, I think.
Yes.
Because since it does not actually give giving us the combined strength. So it is not comparable. This is my idea. And another issue is actually it's a complex. If it is circular or a round column, then it's fine, because I was in Building Research Institute, Japan. Then in laboratory, we have tested several specimens. So it's a circular section, rectangular section, and breadth width ratio, different ratio. So the best result we got is for the circular section.
Yes.
Because of this, you see, ferrocement or whatever material for confining, if we can confine. So, but if the ratio, if it is a rectangular column, then as the width to length is more and more length, the result will go down. Result will be less effective.
Yeah.
So actually, we don't have the exact design. I don't know. So
Yeah.
I think
Actually,
Patankar sir may.
yes, Mohammadji, you have very rightly pointed out these are the two areas where we have still to work more. First is about the perfect design based on how much increase in the old strength in the old structure we want, and with how much thickness it will give this much increase. So in this way, we have to be perfect in designing itself. At that
Yeah, yeah.
then only we will be confident enough to do this such kind of strengthening. And the another point we have also rightly pointed out that about the testing, because this NDT is not the foolproof testing which can be ascertained for the increase in the test. As Devika sir has suggested, there has to be some prototype testing or maybe some kind of field testing where we have to still work more. I think we will take a last question.
One thing just I want to add, even what I have done, one column is more than twice the width and length ratio. Then we have suggested to nail to anchor at the middle of the column in the long direction, so that it can the confining force become it's a better it can give confining effect. Thank you.
Yes, yes. Thank you. There is a one question by Dr. Kalyan Sundaramji. He has asked whether the strengthening of the old Wardas in Pune city can be done and whether it can be evaluated by NDTs.
Because that can be done, but it's very complicated because these Vadas are very old and their original strength has been reduced drastically. Fortunately, in Pune, we do not have the consideration of seismic, so they can be strengthened by using shear connectors and local strengthening of the Vada's original material and then ferrocement lining. Certainly, we can strengthen to a certain extent and to an extended life, but that is not a long and permanent solution. That can be a temporary solution for 3 years, 4 years, but it can certainly ferrocement can be used.
In the another way, how we do the structural auditing of old Wardas? In
So
what
my sorry, I have a question.
It is a very difficult question because you are when you say old Vadas, what is the material of construction? They can be of masonry, they can be of mud and slime, they can be of old brickwork. So it is a very generalized question. And if you have to really go into it, then you have to know the material of construction and the structural mechanism that is adopted in the construction of the Vada.
So my point was very simple. Is there any simple, direct, non-destructive testing method available to say the residual strength of this structure, it can be a Vada structure or anything, is so and so, and therefore we can know for sustaining the load how much extra reinforcements need to be done, and we have got tables available with us to do it. So that was the part of the question, and then the application to Vadas or to other things can be done later. Because as is, where is there a method to estimate the life or by non-destructive methods?
No. As I told you, the fundamental issue is what is the material of construction of the Vada. They can be very thick mud and lime walls which are old. They can be masonry walls which are very strong, and they can be brickwork, 18 inches, 15 inches brickwork walls. So the material of construction and the structural system has to be understood to do some testing and taking into account all this. Without that, you really cannot do anything. And you cannot do non-destructive testing on mud walls or stone masonry. You can do in brick, but it is very limited in nature, and the past results are not showing any good thing. But ferrocement lining can certainly strengthen the life of the structure for a certain period of time, and we are pretty sure that it will hold till such long-term remedial or new the structure is raised and built. So especially in heavy monsoons, you can do that as a temporary structure, temporary method to do that. So I
Yes.
believe that WADAs are very complicated and cannot be addressed in this particular session. It needs a lot of data and to come to certain logical conclusion. The
Yes.
line of action.
Yeah. Thank
But
you,
I would like
Milinji.
to contribute. I would like to contribute on the strengthening of jacket, the issue of jacketing, because jacketing is a very complicated subject, and what we do is after a lot of research and a lot of work, since we have to sign on the documents for strengthening, I personally adopt a very hybrid technology, and what I do is basically I take the core tests of the column or the beam, actual core test as they are, and then we we actually found out what is the current strength of the concrete, and then we do half cell potentiometer test to ascertain what is the level of corrosion of the steel in that concrete. This is very important. Thirdly, we inject a single component monomer which is having low molecular weight and which goes very easily into the old concrete, and it completely fills the voids. It is much better than epoxy, and it serves the purpose of closing the voids and giving higher strength. Fourthly, most important, the steel that is corroded, you cannot do anything about it, but latest technology that we are using is called bipolar corrosion inhibitors. You have to spray bipolar corrosion inhibitors on the concrete surface, and they have an affinity to the steel, and they will coat the steel with that bipolar corrosion inhibitor and stop further reduction, further increase of corrosion of the steel. Now this is very important, and the core has to be strengthened that way. And after that, we take the samples again, core samples, and test them and find out what is the additional strength that is derived. Now in that we add a factor of safety, because the original steel that is corroded, we are only stopping the corrosion. So factor of safety for the steel is considered based on the half cell potentiometer test. Now further to that, we put shear connectors, and we use a very high epoxy bonding agent which has a bond strength of about 3 to 4 MPa, 40 kg per centimeter square, even 50 kg per centimeter square, because we are converting a heterogeneous concrete to a homogeneous composite by adding a ferrocement jacket. And then
Yes.
these shear connectors are connected to the ferrocement jacketing. And for ferrocement jacketing, we are using 100 by 100 by 12, 50 by 12, and 25 by 12 GI weld meshes, no chicken meshes, and micro concrete is poured of M60 grade or even sometimes M80 grade. But this micro concrete has a very special capability of having dual shrinkage compensation. What is called dual shrinkage compensation is while curing the concrete there is plastic shrinkage, and while drying the concrete there is mortar, there is shrinkage. So both the shrinkages are compensated in the mortar only. So this prevents cracking of
There
the
are
newly
many
repaired
such
structure.
where the
So
strengthening
what
can
we
be
do
done
is,
by is.
and what we do is at the end of the day, we calculate the core strength with a due factor of reduction, considering what is the new core strength achieved after the injection of the single component monomer, and what was the original level of corrosion. We reduce the core strength, and then we add our ferrocement strength, and then finally one more reduction factor for the bonding effect due to old concrete and new ferrocement. So
Yeah.
this is the way we do it actually, and this is, I believe, has worked well, and it has withstood through a period of time, and
Yeah.
that is what I have been doing.
Yes. Thank you very much for such a elaborative explanation. And just to add to that, Dr. Sundaramji, there are many methods of structural auditing that can be done for any old building or any bridge or any that kind of thing. But it's certainly depending upon the material, the type of material they have used for the construction, as Milinji has rightly said. Okay, now I think we have already more than our time limit. Let us thank at the outset first to Dr. Subhash Patankar sir for the presentation on the strengthening with ferrocement. He has opened a very excellent topic for today's discussion, and with a case study, he has proved that it is certainly economical than any other method of the jacketing purpose to the any old component. We have got the detailed explanations from Dr. Divekar sir, as well as the experiences from Mohammad Sadiq ji. I'm very thankful to them also. Finally, as a conclusion, we found out after this presentation that there are still two areas to be worked out. We need to work more on these. The first one is about designing the jacketing or the retrofitting in detail, uh, particularly the percentage increase required, which is correlated directly to the thickness of the jacketing. This is the one area. And the second is about the testing of the composite component after the jacketing. So in these two areas, we need to work more and do some more refinements also, so that with confidence we can use this technology for the strengthening of any old building. Well, thank you very much again, Dr. Patankar sir, and all the participants.
Bye. Goodbye.
Bye.
Thank you, sir.
I'll be in touch.
Chalo.
Yes, sir.
Thank you.
Thank you. Thank you.
Thank you to all.